So let me get to question 2. That's the question I'm trying to answer right now. Yeah. So many of the questions that I haven't yet done, they frankly weren't done because they were easy questions. Like this would be an example of that. It's an easy question. I thought it's something that people could figure out relatively easily, just thinking through geometry. That's kind of why I haven't done it. But I'm a completionist. I'm here. This is one of the few remaining questions that I need to do to just complete everything. So let me do this. This is question 2. And this is one of the questions where everyone will get it as question 2. There's no question pull behind it. So you have someone who's standing in front of a flat mirror. These kind of ray diagrams give you some idea of, and the rays come from foot, reflects off this edge of the mirror, comes to the person's eye, top of the, reflects off the mirror, and then comes to the person's eye. Good. So suppose a man stands in front of a mirror as shown above. His eyes are that, should I label? Let me leave it. I think I can do without the label. Find the height above the floor or the top and bottom of the smallest mirror in which he can see both the top of his head and his feet. Height of the top of mirror above the floor. So it's a geometry exercise. I think I can do it here. So with the geometry exercise, I do think it's geometry is one of the things that I find hardest to teach. A lot of it is kind of intuitive reasoning, which means to someone it might be obvious, and it's hard to explain that obvious thing to another person. I think the one advice I can give is the value of drawing auxiliary figures. So I can kind of, draw some straight lines here and there. And as I do, I can kind of see these angles are the same. From law of reflection, these angles should be the same. And this is 90 degrees, this is 90 degrees, which means these two right triangles are similar. So this right triangle here is similar to this right triangle because they share this angle and they are right triangles. Now, because they share this side, they are actually more than similar. Because they share this side, they are actually congruent to each other. They are the same triangles. So from that, you can argue, oh, these two lengths are the same. Which means whatever the height of his eye is at, this height here, so let me label that height of his eye, capital H. This height here must be half that from that geometry. And, some of you could have just stared at this for a while and then figured out, oh, yeah, that's half that. So 0.925. Oops, no, updated. So you might have just intuitively figured it out. Okay, great, wait, that's not top. It's bottom. So for the top, you need to think through a little bit more. But I can just label. So same argument as what I made here will apply for these very narrow sliver of right triangles. And it does amount down to when you have this total distance of delta x to the top, then this, top of the mirror to the kind of height of his eye, this distance will be that delta x divided by 2. So from his eyes to the top of his head is that much higher. So it's this top of the mirror is higher by half of this, 0.085, 0.085, so 1.935. Let's double check to make sure that I didn't miss them. Doing this in my head, sometimes, I'll make mistakes. My biggest trap is the kind of calculation where I think I can do the mental math and I can't. So what is the ratio of the distances between the 2 points to the man's, so between the 2 points, that's 1 to the man's height, 2, so 1 over 2, I think. Oh, 0.5? So yeah, that's this question. It's the kind of question that a lot of people can answer intuitively. That's why I haven't done it before. Now I've done it, so I don't have to ever do this question again. So with the geometric optics again, what I recommend is draw some auxiliary figures that might help you see the congruent angles or congruent triangles, congruent segments. I think that's the most advice I can give. And sorry, I have a systematic way of teaching when it comes to algebra and other types of problem solving. With the geometry, I find it very hard to give you systematic advice, which is why I say I find it hard to teach you geometry.